Okay, great. So, hi, my name is Vipul. I work as a senior software engineer at GeekyAnts and primarily work with NativeBase. My interests are in developer experience and tooling, which is basically what I do at work. I go by at the rate Vipul Bhardwaj on the internet. So, the username is a little bit of a story. So, you can DM me to ask. And I love sunrises because they remind me it's time to sleep. So, now you know what time I sleep. Cool. So before we start, there is a tiny bit of information that we need. So some people will say that some sides of this talk are a little wordy. What that basically means is there is a lot of text on some sides. The reasoning for that is if say somebody in the future got curious about how the this whole thing about utility crops came to, about to be, the origin of it, and if they traveled back in time and somehow ended up finding the slides, except the video, right? The slide will make no sense if the companion video is not. So, for a time traveler coming back to time, some slides have a lot of text. They're not supposed to be read by you because here I'm standing and you can hear my beautiful voice. And so just don't read the text. If you find a slide with a lot of text, just don't read it. Focus on my voice. But if you still want to do something, you can drop me a DM saying I have a great voice and I should start a podcast. And the de facto reply to all those messages is I know, right? With several sad face emojis. So try that. I'll do that for you. Cool. So let's jump on our content and get serious a little. So this should be really familiar to everybody looking and doing React Native development for a while. We are creating a style sheet and it appears that we are going to use some sort of a button. We have several fields, but that's not important. Then I create a button component, which is going to be my abstracted component called button with the styles that I supposed to write before this. This seems straightforward and correct if you are not aware of the certain details. But this example has a de facto flaw. So first up, this won't work for a button component that's imported from React Native because the styling on the default React Native component is extremely limited and it only supports a handful of components. That's why you see in the example, I've never imported the button component from anywhere, right? So now, how do you do that? So the default for this is you use a touchable opacity container and then you use that, right? Several component library gives you a button component that is actually a touchable opacity component, and then they are hiding it in certain details. So if we are talking about implementation correctness, that's what is happening here. The button component is not actually being imported from any React Native. It's say it's imported from NativeBase, right? Now, this example on the surface seems straightforward, but it has an inherent problem with it, right? So let's talk about that. The problem here is the cost of context switching. But this seems like a straightforward sentence if you look at the surface of it. But we'll dive into details of how this problem actually came to be. So separation of concerns, right? Now, separation of concerns is basically an idea that is propellant into writing more maintainable code and on folks who are older and force you to write test cases. Those talk about this jargon, right? So they'll say that you should separate your files in modules that work in isolation and have something specific to do with it. So you should write your markup in one file and you should write your styles in one file and keep them separate only to link them whenever they are needed and with the minimal information, right? And this jargon is populated by folks who want to get a higher salary called architects. So this is what it is, right? So commonly, how React Native developers and the community interprets this is you should keep your markup and your style separately. So you'll see a lot of React Native projects where they'll have their style sheets in one file, like the CSS approach a little, because a lot of React Native developers came from the whole web ecosystem, right? And then they'll have their markup and then they'll use that, import that style object, do something like the one we did in our previous example, right? But what is the problem here, right? What is the inherent issue with this approach, right? The separation of concerns, right? It's a good thing. It's a tried and tested approach. It works, but not in all contexts, right? In your context, this might not be the right solution because there are several. And the biggest problem with this approach, say, separation of concerns in the ecosystem we work is actually there are two. So one is context switching. So say you want to edit, you went to your design, right? You saw a button, you looked at the button, and then you thought, okay, it shouldn't be red, it should be blue. Now you are currently reading your markup because you ended up finding the button. But if you want to change the style, you have to navigate to a different file, then go there, then basically change the content and come back to your markup. This is at least 3 clicks or keystrokes on your keyboard that you have to do constantly being a UI developer, right? On React or React Native, whatever side, right? So this has you switching context a lot. So you're going constantly going from your markup to your styles, from your markup to your styles. And that takes a lot of work on you. Right? So that is what I mean when I say the cost of context switching. You're constantly switching context. You're constantly going from markup to style sheet, markup to style sheet. And if you do it long enough, you observe this equation. So the productivity is inversely proportional to the effort you put in context switching. How? So what happens is basically you navigate from your files so much that you start to find information leaking in your head. You're currently looking at a file. You think it's the markup file. It's affecting the markup, but actually it's affecting the styles. And again, the problem with globals is that you might change one part of your code thinking that it's local to some given module, but it might not be. You might think, and your company standard might be such that a module goes with a specific component and stays local to that. But some developer who just joined your team could see the style he wants to use being on a single file already, and they might just refer it to that. And on large code bases, you can't specifically highlight this problem in all PR reviews. You see an import, you go to that file, you see the exact files being loaded and the exact styles being imported. But that module was not supposed to be used by that, right? So this takes a lot of time in code reviews, writing code, making sense of code, etc. So productivity is inversely proportional on large code basis to the amount of context switching you do. Right. So what is the alternate here, right? So how about we propose utility props? Now, what utility props are we'll look at in a little bit, but let's look at this example first, right? So you'll see that there is no style attribute at first, right? So basically, we are not styling this component by a style sheet. That goes out of it. Then what we are doing? So we have certain props. So the first one is called size and has something called an MD as its value. Okay, maybe let's move forward. Then it says border radius code. Now this is more familiar to me. If I have zero knowledge of this component prop or utility prop system, then I can still read this border radius is 4. Okay, I have a border radius on this button and the value is 4. Makes some sense, right? Font size, font weight also makes sense. The SM medium values might not, but okay. And the light and dark prop also make a little sense because I all applications these days have a dark mode and light mode, so I kind of know what this means, but not really. So, but it's not about reading code, right? Currently, here it's about feeling code, right? So, see, previously you had context, now you don't. And also the other problem of having global modules which could be imported by anybody, there was no code related restriction there. You couldn't force that rule. Okay, maybe you could write ESLint, but that's ESLint, not your code, right? Here, the de facto is all modules are going to be local. And why is that? Because it's written in a utility style. You are not writing style sheets. That whole global style sheet approach goes out of the picture. So now let's look at the details of what these props are actually meaning, right? So what are utility prop anyways? So it's a more declarative style of writing components using a collection of UI props. Now what are UI props? This values that you see, size, border, underscore text, has some font weight, font size, then the right mode has a background, BG obviously means background. Dark also has a BG, which obviously means a background, and they have some primary uh, thing, token, right? So if I'm reading code and I have some previous escalations or exposure to design systems, then I can clearly see that, okay, this now refers to a primary color whose texture or shade we are using the value 900. This basically means to the how dark or how light a particular color is. So we use shades. This is very common in today's design systems. So if I have that kind of exposure, I can still start reading it more, right? And this is a declarative, right? You're not writing the style sheet from hand. You're saying, give me a border radius of 4. Now, this border radius 4 comes from the utility prop resolution system. You're not saying I'll write 4 pixels for web, then I'll write 4 DPI for Android and such, right? You're just saying a 4. Now, this 4 has to make some sense and a meaning in a context, a bigger design system context. But that the inherent system is doing for you, right? With this, we can reason more easily about certain parts of the code, and this involves less context switching. That is the idea that this came about to be. You are not moving in files and then reasoning about certain parts of your code. How? So basically, if I see a button, right, that says a border radius of 4, then I can clearly see this button as a border radius of 4. Before, I just saw style, the style object. I didn't know what was inside the style object until I saw that, right? So I can reason about my code more locally and more easily with less context. Now, the third point is the more important one, which actually causes a lot of friction in the utility props community. So people somehow relate utility props to the idea of utility classes, which was actually popularized by the library called Tailwind and such. So there were ones previously also, but the Tailwind was the major one that popularized this idea of utility classes. And what utility classes are, it's a web-related concept that Tailwind popularized. And you have class names for all the information that you could write separately. And then you write those in your class attribute already, and then those styles are applied to you. So you don't actually write the CSS. The CSS is given to you. You just use the CSS selectors in terms of class names, right? This approach is not that. It was inspired from utility classes, but it's not utility classes. And since it's not utility classes, it doesn't come with the baggage of having you to memorize weird names for classes, right? So that is an argument that a lot of people don't like about utility classes, because you have to memorize a lot of class names and they sometimes can be weird. The names could have certain attributes that don't really make a natural sense. So that baggage is not here. Utility props are not a utility class, but they were inspired initially by utility classes. So why do you we use those at NativeBase? So I'm glad you asked. Find out. So why do we like utility props? This point is more about, so the first one is you are not wasting energy writing selector names for your components. What this basically means is, if you go back to our initial example of a button having a style, and the style was style.mybutton, right? Now my button is an extremely bad selector. This tells me nothing about the button's property, right? I could not interpret a single thing about that button's behavior with the name my button, right? And if you wanted to write a good name for that button, you have to think, right? If you ask somebody who has been doing programming for a long time, work on several big projects that span over a year or three or somewhere that range, right? They'll tell you that finding good names constantly for things actually becomes a lot of pain after a point, right? Because some junior folks on your team might not like that approach. They might think it's a waste of time, but you know it's actually important for codability and maintainability over a long period of time, and you know all that other jazz, right? So it takes a lot of energy, write good name. And loop modules with utility props take that away completely. So we handle that for you. You don't have to do that, right? Again, context switching. So as developers and as library authors, we really care about your productivity, and we don't want you to be wasting time switching constant context constantly. So we have that. And the most important one is making changes feel safer, right? So because we have kicked out the global CSS approach out of the picture completely, so every single thing that you write is local to the component that you're writing it for, not even the module. It's local to the components itself, right? So you won't never have a case where you just wanted to change the green to blue on a specific button somewhere in your application nested deep in 50 components, and then you thought that you okay found the exactly global style that you're supposed to be changed, but then you pushed to production on a Friday evening and went back home, and then you came back on Monday with a really big manager red face shouting on you because you changed all the buttons to blue. That possibility is out of the picture. That's not going to happen if you use NativeBase, right? So again, and the fourth point is that it allows us to provide developers with more intuitive and declarative ways to customize their UI components, and we'll see how exactly. So look at this example, right? On the surface, looks really straightforward, but see the uh, clarity you can get from using certain names, right? So it has a prop called px, right? And if you have any experience, you clearly know that this is padding on the x-axis, right? Now what does the x-axis really refer to? It's right and left, right? So the padding on the right and left of the component is 4 units. Now this 4 native base units is very specific, and I'll get back to it in a second. But let's talk about py. Now once you have seen px, if you couldn't see it before, now you can clearly see that this is talking about the y-axis, and that is indeed what it's talking about. The empty, now you can also figure out, is for margin top, right? Now let's look at these things called units, right? NB units, the native base unit. What is this exactly? So native base is platform component library, right? We compile to, or we ship on iOS, Android, and web. And we are increasing support for web, right? So Android, iOS, native has it figured out. Web, not so much. So we have to do certain optimizations for you so that your experience on web is consistent to what you're expecting out of your components, right? So this 4 is a native base unit coming from the design system. We give you the customizability to multiply this with a token on web. So basically, this 4 on Android is supposed to mean 4 DPI, and on 4 iOS, it's mean to the 4 units of margin that uh, is there on iOS. But you want this to be 16. Your base is 4. You want this to be 16 on web. You can easily do that. If you go to the style sheet approach, you'll have to fight the style system to do this for you. You'll have to write a lot of conditionals for this. You have to write a lot of platform specific conditionals. You could, in native base, you could just specify that base value in your design system, and the design system will take care of that. So the counter argument to why one should use utility props has always been, why would I not just write inline style, right? And that argument somehow works on web, but fails completely as you come to the native ecosystem. Because in native ecosystem, can't really do that. You have to use the style attribute, and then all the problems with the style attribute come back to bite you. Also, some other things, right? Doing a style system with stylesheet.create is hard because you'll have to follow a specific system, and the export, basically deriving something from already existing style sheet, is hard. You have to rely on JavaScript to actually do that for you, and you'll have to write a lot of code. Plus, if there is no design system, then writing 16 is just a magic number. It doesn't make any sense on the design system basis, right? Your application has 60 in some place and 12 at some place and 5 at some place. All the magic numbers are in the picture, right? So there is no type forcing you to write a design system. You could write anywhere, and that can bring in a lot of inconsistency through your application. So with utility prop and design system that backs that utility prop is what the database provides, it becomes easier for you to write consistent logic throughout your application. And the same goes for color modes. So if you want to do a dark mode, you want to do a light mode, that's extremely easy for you to do. If you want to do responsive design, so on web, it should look a certain way. On screen sizes of small to medium devices, it looks a certain way. And then if you go from large to any width device, then it should look a certain way. Then it also becomes easier with NativeBase since we have props for that. So you can toggle display based on the media query sizes, so small, medium, large, extra large, etc. You could easily toggle certain things to display or not display, and also change the behavior side, right? So that also becomes easier. Before that, if you had to do it with style sheet, you have to write a lot of if else, if else. So that's out of the picture. You are not doing that. It becomes extremely easy for you to do that. Again, the same thing comes from style and event-driven things like hover, focus, etc. So if you do that, you'll have to write special conditionals in say dot hover etc. This also becomes extremely declarative. You just go underscore hover, and then you specify what should happen when this is hovered. You don't really care how this thing is getting hovered. You just say, if this thing is hovered, give me this. And then it becomes more declarative for you to do that. You don't actually do it yourself. You just say, if this is this, then give me this. Cool. So another question that a lot of people ask is there maintainability concern? And I'll tell you why they ask this. So the inherent idea is that how you write components that have certain specific features composed into themselves, and you want to add them. So it's basically like creating a class and extending it, right? So how do you do that with utility props? And the inherent idea is you do something like this. So if you go back real quick to our first slide, right? Imagine this not being the style, but having utility props. So if people imagine a utility prop approach for creating components, say a rounded button to be something like this. So I'll say create a component called rounded button. Then I'll pass it to props. Then in my button, I write my utility props that make the button look the way I want it. And then I write props for children. And then I create a child component abstraction where I'll put my children. So I've taken the button from NativeBase, I've added my de facto styles in there, and then I got the rounded button. This approach, while can work, is actually the favorite of people who want to write maintainable code. So to that problem, what NativeBase gives you is a concept called variants. But before we talk about what variants are exactly, let's talk about why would you ever need one, right? So imagine in a typical application, you have an alert, right? An alert is a thing, a UI component that everybody might be familiar with. They represent a lot of state actions changes, right? So if you fill a form, there are possibilities that it went successfully, it had some failed. Maybe you want to give some feedback information to the user, right? So these are extremely common with various states called success, failure, information, etc. Right? And the great thing about alerts is the base structure, the base style of every single alert is same. There are just a few properties like color, etc., which impose a visual lead on the user looking at that thing. Emotional contrast to a color, right? Emotional reaction to a color. So they have slightly different colors. All the things that you want to convey. Now, to do this, you would really love to have a base container that composes of all the styles that an alert has. And then on top of that, you will apply the ones that are specific to that, right? For this, you can use a variant, right? And what a variant will do is use a base style that is the base for all the other. And then it will allow you to create a different variant for each. So you can have a variant called test, you can have a variant called information. And then all those variants could differ slightly from the base, right? And if you want to learn this variants in detail, then you could go to doc.nativebase.io/customizing components. And there we talk about variants in detail. But for the presentation sake, let's look at an example that's sane enough steps, right? So what we are doing here is we are importing React from React, and then we are importing certain things from NativeBase, right? So the first thing is called NativeBase provider, and it's nothing but a React context which actually contains NativeBase design system. The colors, the theme, etc., all the tokens that are there in NativeBase, those are contained inside this NativeBase provider. It's just a context that has our design system, right? Then we have our buttons, etc. Now there is an interesting function called extend theme, which is basically your gateway into changing our design system before you initialize it. So how you do that is you call the extend theme function and you pass it an object. What you can do in that object is you can change certain properties about the design system before you initialize the design system in the context. So here what I'm doing is I'm going to component. I'm going to the components, which is all the components that are there in NativeBase. I am selecting the button one, and then I'm creating a new variant called rounded. Right? This function will be paused all the props. I just want to play with the color scheme one. So I picked out the color scheme one via destruction. And then I provided some properties, right? So the background is going to be color scheme or whichever color I'm going to get dot 500, which is just a shade token, which is somewhere in between. So not the darkest, not the lightest, somewhere in between. And rounded is full. Basically, we are saying this is the property that comes with native base, by the way. Rounded full is a token. Full is a token. It specifies a certain amount of roundness on the corners, right? And how you consume is extremely straightforward. So the above before line number 5, where you see button color scheme emerald, all the above information is just implementation detail, but the second line has the theme equals theme, which is where you're passing the new theme that you updated or you customized with extend theme, right? So you're initializing the context with a customized theme that you have written on top of native base default theme or design system, right? Now The first button, you say the color scheme is emerald, which is what you'll get with the default button. But on the second one, you add another block called variant, and then you say rounded, right? So that's the only difference between those two components that we have used, right? And the results differ significantly in terms of the borders, right? So you see that the one on top is the one which has no variant, which is the default button of NativeBase, right? Then you created a variant called rounded, which if you use on any button will give it a full round on the button, right? And the color is also using a slightly different shade, which is the 500 in between all the shades of that color. So our colors in native base go from 50 to 900 with the first increment being 50 and then 100. So 50, 100, 200, 300, etc. 900. So the colors are slightly different. And the second button is button with rounded corners, right? And the only change that you had to actually do to make this button have all those styles is just add that variant, right? So variants make the composition of information extracted out of writing the component there. And if you want to make it more reusable, you put it in a variant and then you can just use a variant and use it throughout your application, right? So this is how you do that. And these were the main points that I thought were good enough to highlight in a presentation as short as this about why NativeBase chose and loves utility props. But there is a lot of more information that sits on the docs.nativebase.io and also nativebase.io, which is our homepage for our documentation, etc. So browse through our documentation and you'll find a lot of information which actually, so the more you read about utility props, the more you work with them, I'm sure you will love them more, right? So if you get time, try utility props and then give us your feedback on how you like them. So yeah, that was my time. Thank you so much.